Welcome. Today's video, we're talking about section 8.3. We're probably going to break this up into two videos. The first video today, we are going to talk about how to integrate products of powers of sine and powers of cosine. And then next video, we'll get into secants, tangents, and there are some further topics we may cover in this section as well. So the first thing that's important to talk about is what trig identities are going to be helpful. And so, of course, we have our Pythagorean identity, your favorite trig identity, sine squared plus cosine squared equals 1. And you can use that also if you want to talk about like secants and tangents and cosecants and cotangents. By dividing both sides by sine squared or cosine squared, you can get the other versions of the Pythagorean identity. Two other helpful formulas, we call them power reducing formulas. And so if I have sine squared or cosine squared, I can reduce that to 1 minus cosine of 2x over 2 or 1 plus cosine of 2x over 2, depending on if I have sine or cosine. So these are super helpful, and you'll see why in a second. So we're going to do one quick example, and then I'm going to give you some tips about when to use which identity. All right, so our first example is sine to the fifth of x times cosine of x. So this one actually is just a simple u substitution. So if I let u equal sine of x, then du dx is going to be cosine of x. So then I get my good old friend dx is du divided by cosine of x. And then if I go back to my integral, I see that I have u to the fifth times cosine times, and then my dx was du, and then the cosines will cancel. So then I just have the integral of u to the fifth du, which then is u to the sixth over 6 plus c. And then I'm just going to substitute back in my substitution. So then I get sine to the sixth of x over 6 plus c. Hold on, my dog might bark here in a minute. I hear him getting started, so I apologize if he does. Okay, so this works out great if we have an odd power of sine and one cosine, then things are going to cancel and things just work out so well. All right, so some helpful tips when you don't necessarily have that. Here's what we look at. Okay, so our first thing is when we have powers of sine is odd and positive, save one sine factor and convert the remaining cosines. Okay, so what I mean by that is if I have, right here, if I have an odd number of sines, I'm going to save one of them, and then I'm going to convert the other ones to be a cosine. And how I convert the other ones is use my Pythagorean identity there. Okay, so I have that one left over for my u sub to cancel when I do the u sub. Okay, same thing if I have an odd power of cosine. So if I have an odd power of cosine, I'm going to save one of those cosines for my u sub. This is going to be an even power of the cosine. And then I am going to change those to be sines. So we're going to do these in the next example, so you'll get some practice and see what this looks like with actual numbers. And then when both the powers of sine and cosine are even and non-negative, we're going to make repeated use. Oops, I forgot to include the rest of the box here. Okay, I will make sure it is included on the notes that I upload, but you're going to make repeated use of those power reducing formulas. So the other one is cosine squared of x equals 1 plus cosine of 2x over 2. And what you're going to do in that case is once you plug those in, you will find that it will be easier because you'll have less powers and everything will be in terms of cosine. So we'll do examples of all of these and you can see what it looks like in action. All right, so here's our first example. So our first example, we have finding the integral of sine cubed of x cosine to the fourth of x dx. And for this one, we have an odd power of sine. So what we're going to do is we're going to rewrite that as sine squared of x times cosine fourth of x, and then I'm going to peel off one of those sines of x over here. Okay, so all I did was split up that sine cubed into sine squared and sine, and then my sine squared, I'm going to use my Pythagorean identity. So that's the same thing as 1 minus cosine squared And then I have cosine 4x sine x dx. Then the next thing I'm going to do is I'm going to distribute all of this cosine to the fourth sine x to both the 1 and the cosine squared. So then I am going to get the integral of cosine to the fourth x sine x minus the integral of cosine to the sixth x sine x. And so I'm going to let u equal cosine x in both of those. So the derivative of that is negative sine of x dx. So then my dx in both of these integrals is going to be negative du sine of x over sine of x, excuse me. So then when I do my u substitution, my first integral, I get u to the fourth times, and then my sines will cancel, du, but I'm going to have a negative left over. Okay, so I'm kind of skipping some work here, but I think you can follow. So I just substituted in my dx, canceled, and there's a negative left over. So canceled that sign. And my other integral is minus, and then I'm going to get u to the sixth, and same thing's going to happen here. My dx's will change into a du over negative sine of x. So I have a negative here. So I'm going to change that to a positive since I have a negative and a negative. So now I can go ahead and integrate, and I get negative u to the fifth divided by 5 plus u to the seventh divided by 7 plus c. Go ahead and substitute back in my cosine. So my final answer would be negative cosine to the fifth of x divided by 5 plus cosine to the seventh of x over 7 plus my good old friend c. Okay? All right. Let's try another one that's a little trickier. So in this one, we have a definite integral, and we're evaluating from pi over 6 to pi over 3 of cosine cubed of x over sine of x dx. All right, so this one we have an odd power of cosine. So I'm going to rewrite that numerator as cosine squared of x times cosine of x all over square root of sine x. And then I'm going to go ahead and change that cosine squared to 1 minus sine squared. And then what I'm going to do is I'm going to just divide that first term by my sine x. So if I do that, oops, I forgot the square root of sine x. So I am basically, let me just rewrite that step. So if I write it like this, then it's a little easier what I'm doing. So I'm dividing 1 by square root of sine x, so I get sine x to the negative 1/2. And then sine squared divided by sine to the 1/2 gives me sine to the positive 3/2. And all of that is being multiplied to cosine x. Add my bounds and my integral here. Oh, Philip, don't start barking now. All right. Got that. Great. So then what I'm going to do is I'm going to let u equal sine of x. So then we find that dx is going to be du divided by cosine of x. So then my cosine is going to cancel once I substitute that back in. So now my integral in terms of u, got to make sure since now we're writing it in terms of u, my bounds need to have that x on them to clarify that pi over 3 and pi over 6 are not in terms of u. So then I get u to the negative 1/2 minus u to the 3/2. My cosines will cancel, du. And then I'm going to go ahead and integrate that. So I get, let's see, add 1, so u to the positive 1/2 divided by positive 1/2. Sorry, Philip is growling at birds in the yard. And then u to the 3/2 divided by, u to the 5/2 divided by 5/2. And all of that is evaluated from x equals pi over 6 2x equals pi over 3. Great. And then I'm going to go ahead and substitute back in my signs. And I'm going to flip those fractions as well. So I get 2 times the square root of sine x minus 2/5. Oh, I'm just going to leave it actually as, that one I can leave. 2/5 times, and then sine x here to the 5/2. Okay, and I'm evaluating now. I don't need to write the x. So then I plug in pi over 3, and I get 2 times the square root of 3/2 minus 2/5 times square root of 3/2 times 5/2 minus square root of 2 minus square root of 32 over 80, which you can figure out on your own. I'll let you do all that fun stuff, which plug into your calculator is approximately 0.239. Okay? Fantastic. All right, if you need to use the unit circle when you're evaluating these, make sure you have it handy. You kind of have a link to it super quick for yourself. Okay, our last example. We're going to make use of that power reducing formula. And how we know that is here we have an even power. We don't have an odd power of either sine or cosine to work with. So we're going to make use of that fun formula, and we're actually going to do it twice. So first thing we're going to do is we're going to rewrite this as cosine squared of x all being squared. And then the inside of that, I'm going to rewrite as 1 plus cosine of 2x over 2, and that's squared dx. I'm going to pull out the 1 over 2 squared, so I'm going to pull out a factor of a 4th just so I don't have to worry about it. And now I have 1 plus cosine of 2x, quantity squared. And then I'm going to FOIL that bad boy. So now I'm going to get 1/4 times the integral of 1 plus 2 cosine of 2x plus cosine squared of 2x dx. And then I have an even power of cosine again. So I'm going to go ahead and use that power reducing formula once again on this last term over here. So I get 1/4, and then I have 1 plus 2 cosine of 2x. And then this here is going to turn into 1 plus cosine, and my inner function is 2x, so I got to make sure I double it because that's what my formula tells me to do. So now I have a 4x all over 2 dx. And then I'm going to go ahead and separate these as separate integrals. So I'm going to get the 1/4 times just my integral of 1 dx plus I'm going to pull out the 2, so I'm going to get 1/2 cosine of 2x dx plus, and then I have this first one as 1/2 times the 4th gives me an 1/8 dx. And then my last one is going to be that 1/4 cosine of 4x. Oh, nope, it's going to be 1. Oh, yeah. Forgot we have the 1/2 on the inside there. So 1/4 times cosine of 4x over 2 dx. So I'm going to have an 1/8 there. All right, so let's take a look at these. So the first one, I can combine the first one and the third one. Those are like terms. And so I'm going to get a 3/8 there, x, after I do my integration. And then for this one here, if I let u equal 2x, I'm going to see that I'm going to have sine of 2x times 1/2 after I divide by that derivative there. So I'm actually going to have 1/4 sine x 2x. And then this one over here, remember we have a 1/8. So I'm going to get 1/8 times. And then here I'm going to let u equal 4x. So then I'm going to get 1 over 4 sine of 4x plus c. So my final answer would be 3/8x plus 1/4 sine of 2x plus 1/32 sine of 4x plus c. If I went too fast through some of that integration, take time and do it for yourself, where you let u equal that inner function and go through and you can see the factors that are then going to come out of that. I'm going to start skipping some of those steps from now on because I think some of those should be more routine by now, and that way I can save some time on the videos. But if you want to go through any of that with me in detail, I'm happy to do so. All right, so go.